Hey guys, thought I'd show you a quick little project I worked on just the other day. React hooks just came out and it's kind of a big deal. Everybody's freaking out about it. So am I. And at first it kind of felt weird, but now it feels pretty great. So I went through and kind of tried out some of these hooks as Dan was talking about it and Ryan. And I thought, hey, like I have this quick idea for a color matching game. So I thought I would kind of like put it to use building this color matching game. And it actually turned out pretty cool. I had some struggles at first because I was writing hooks like I used to write classes. And like I got done with the first version and I was like, what the heck? This feels so weird. And I found out that I could just like delete a ton of code and stop doing things the way I thought they needed to be done. And it turned out really cool. So I'm just going to run you through some of the code here really quick. So this is on Code Sandbox. I love Code Sandbox, by the way. You guys should use it. I've built entire open source libraries on Code Sandbox. And it's just so much fun. So let's get rid of that so you guys can see this. All right, so I've got some styles just some style components that I built in this file over here. In fact, I'm going to put this link on the chat so you guys can go check it out if you want. So fork it, check it out, follow along if you want. But there's some styles here that I'm just building with Emotion, React Emotion. It's just like styled components. It's just CSS, not a big deal. But these are just a bunch of styles. Nothing you need to worry about right now. And I import those components into this. So since I am building a game and there's going to be some animation and some like looping, I'm using something called RAF, which is just a polyfill for request animation frame, which is probably one of the best ways to do games on the web, in my opinion. All it does is uses the browser's request animation frame API to let us do animations, hopefully at 60 frames per second. So this game is really simple. I'll give you an overview of the game, then we can dive in. It says match the colors, start game. And I'm using some CSS here to make sure that the text is more or less always readable. But let's see. It starts cycling through, so okay, we have this random color on the top and then this one's cycling through, and we click stop when we think it's close. Now if you notice, it didn't move that much, but now I'm going to stop it on a color that's clearly not the right color. Oh, boom. Okay, so basically the width of these boxes is our life bar. And the closer we are to the color, oh, you see right there, I actually just got a 99% match right there. So it added 5 points back to my life. And actually, if I get 100%, it should give me 10 extra points. So there's another 5 point. Let's see, here's a, no. Yeah. It is a hard game, but if you get it exactly 100%, it gives you 10 extra points to your life. And you go until you run out of life. And then it says game over, you got to level 11. And then it has some link and then it says play again. So that's the game. It's really simple. You just hit play. You can use the space bar too, try and match these colors. And it gets faster and faster. Oh, I just got a 10, 100%. The cycle gets faster and faster every level that you go on. So at first it might be like, oh yeah, this is like pretty easy. I can get these pretty close. I'm not losing that much life. But eventually it'll get really fast and you'll be like, holy crap. like I cannot handle this anymore. The furthest I've gotten right so far is level 30. So that was definitely relying on some like 99 and 100% bonuses. So this is the initial state for our game. Right here, we have a function that says get initial state, and it gives us some random initial state right here. So run oscillator. The oscillator is what's running this, this value right here of the color. Now an oscillator kind of, for me, comes from like audio engineering, from my audio engineering days, but basically it's just like, it's a cycler. It's a different type of, it's just an oscillator can oscillate or, you know, create wavelengths or interpolate through a specific wavelength. So I called it an oscillator because it makes sense to me. So we're going to say right from the beginning we want to be running the oscillator, and the speed we're going to be running the oscillator at is 0.003, and that's based out of a decimal between 0 and 1. So this is the speed which we start at. This is the level we start at. Now the oscillator start value is going to be a random number between 0 and 1. And then the target is going to be a random number also between 0 and 1. And we're going to start our life at 0, but once we hit start game, it'll become 100, and I'll show you that. And playing false because I wanted to show a welcome message. So as soon as it hits start game, we take away the welcome message. And I just use playing false for that. Here's a function here that helps us get a color based on a decimal. So basically it just uses HSLA to give the hue of the color, uses the decimal against the 360 degrees to get the hue, and then it's always at a 100% saturation and 50% brightness and a 1 for opacity for alpha. And then like this little burster thing, these are actually from Mo.js. Don't worry about these bursters. They're just like for the little fireworks that happen when you get like 99% or 100%. So that's kind of cool. You can go check out Mo if you want. It's a fun little library. It's not the most performant, but it does get the job done. And then now we actually get into our React code. So this oscillator thing that's like running this value over and over again. In my first proof of concept, this oscillator was a render prop. It was like a higher order render prop. And I would say, hey, new oscillator. And then I'd feed in, the run, if it was running, the speed and the initial value, and then I would have a child function that would just be rendering that value of the color it should be. And then I would use that value in whatever I was doing. And that more or less looked like this. Like I had like oscillator, and then it was closing oscillator, and then inside of here, it was like value. Right, and then I was like putting that into like a color box where it was like get color value, right? And on the oscillator I had run and speed and initial value. So I was like, hey, you know what? Like this oscillator component, this is not really it's not really rendering anything, just like any other render prop component. It's not really rendering anything at all. So I decided to turn it into a custom React hook. So let me show you the real app at the bottom here and kind of how it works. So in the end, this is what's getting rendered right here. Is I'm rendering a header which has color match, yay, level, and then there's a color box at the top. So when you've actually started the game, this is the top color box, this orange one, and then it has a life bar. Life is passed to it to make sure that it's the right width, and then it passes the color, and we pass the color of the target, and then we have the score in between these two color boxes, which only appears at the end, so it's mostly hidden unless your life bar is gone. You'll see it kind of like shrinks or like expands into view in the middle, and I put it there just because it was easy. So the score, we don't need to really worry about that much, just some text. And then there's the second color box right here, and this is the one that's actually rotating over and over again. So this has life as well, so to get the width, and then it has the color, but it's using the oscillator value for the color, which is always changing. And when we click it, or when we focus it and, you know, press a key, like to press the space bar or whatever, then it stops it. And that's why we're doing our on-click trigger right here. And then there's also a button at the bottom that's also the other, like the actual manual click trigger if you wanted it. So you can click the stop button. And it also acts as the play again trigger button. Okay, so how are we, the question is, how are we getting this oscillator value without a render prop? And the answer is hooks. If you haven't seen or heard about hooks yet, you should go watch ReactConf, the very first 3 talks. Well, 2 technically. It's Dan and Sophie Bits were the first one, kind of like the same conjoined talk, and then Ryan did the second talk, which was awesome. Ryan kind of showed everybody how to use Ryan Florence. He showed everybody how to like convert over some like things to render props and how to use them, and it was kind of a deep dive. It was really fun. Kind of mind-blowing for the first time when you see it. And then, okay, so right here, basically what a hook is it starts with use. So the linter is going to freak out if it doesn't, but this is basically just a convention, is you should call your hooks use and then something capitalized, like camel case, right? So React ships with a bunch of built-in hooks that you can use yourself. And one of them is use state, and really it's just a replacement for putting like this dot state and using set state on a class, except you can do it in a function. They go into all that, and I don't want to really go into that because they can teach you about that better than I can. But I want to show you how I use it. So use state can take a single value, or it can take an object and just give you a set state back. So I am pulling out, and it gives you back an array where the first value is the current value, and the second one is the set state. So I pass it the initial state, right? And then I'm getting these things back out. And it's just like I'm using a component or a class state. It's really cool. So from those items, then I can say, hey, oscillator, I'll show you this later, this use oscillator, but basically I'm building a new oscillator, and I'm saying, hey, when the React state says it's running, you're running. And whatever the speed here is going to be the speed of the oscillator, and the initial value is oscillator start. Okay, and then it's going to return me the oscillator value. I don't need to worry about how just yet, but this is just really simple. This is just a function that returns the oscillator value, and it's going to be up to date for every render of our app. And then I build the little trigger button, which is really just doing kind of some game state stuff. It's saying, you know, if there's no more life, then you know, hit set playing to true and put life back to 100. Like that's basically the play again button. If there's no more life and they hit the trigger, then just play again. And then right here, if they are playing, I'm just calculating the score, which is kind of convoluted, but it gets the job done. I'm calculating the distance between the oscillated value and the target. And then I'm also calculating the distances. So actually I'm going to go into this because this is kind of cool. So if you're on a color wheel and this is 0, like color wheels are technically 360 degrees, but we're doing it with a decimal. So if you're on a color wheel like this, and say you pick the number at, let's say this is the number that you picked, right? But this is the target. So let's say the target is like, you know, 0.2, and the number you picked is 0.7. Technically, because a color wheel is a wheel, right? It's circular. You could be closer going to 100 and back to 0 and then hitting T versus doing this little segment right here. So you have to calculate the distances between the target and your value, and the distance of going back around up and then looping back around again, and find out which one is technically closer. So that's what I'm doing right here. The distance is the distance between the target and your value. The cross distance is the distance going around the wheel. So basically you just take this part plus this part right there, and you add them together. So it'd be that plus that, and you add them together, and that would give you your cross distance. And then we take whichever one is shorter, and we turn it into a percentage. So 1 minus the cross distance will give us, you know, like, hey, this is the decimal distance between you and the target. And then we take that percentage and we times it by 100 to get the score, and we round it so that we're like always working with a whole number. It just makes it easier for this game. And then right here is where we calculate kind of the special bonuses. So if their score equals 99, then we're going to give them 5 extra points. If their score equals 100, we give them 10 points. If their score doesn't equal either of those, then we're going to, it's 99 points minus their score. So if you get 90, it will be minus 9, basically. If you get 0, it'll be minus 99. That would really suck. But yeah, technically you can't get less than 50% because it is a wheel. I mean, I could make it so that it's a true 0 to 1 like penalty, like a decimal penalty. So you could lose the game on the first try if you got the exact opposite of the target on the very first try, and that would really suck. I didn't make that possible, so you at least have 2 tries in the worst case scenario to get the right color. You'd have to be really lucky, or I guess unlucky, to select the true opposite of the target on the wheel. Most people are at least within like 0.2 or 0.1, like 10% or something like that. Okay, so then I say, hey, you know what, after the score is done, we take their life and we add the points, and if it's negative, it takes away life. If they get the bonus, then it adds it. Make sure that their life is within 0 and 100. And then we increment the speed by timesing it, speed times 1.1. So we're increasing the speed by 10% every time that they click the button. And then we have a new target that we grab, that we just make. And then we say, hey, you know what, if as long as they have life left, keep running the oscillator. But we want to change the oscillator value to a new one. So every time that they click the button, the target and the oscillator starting point just kind of shuffle. So after that, we say, okay, if they still have life, then we're going to increment the level. And that's just more of a visual thing. It's like, okay, I'm on level 1, whatever, just so they know how far they got. Then, you know, the burster, like I said, this is just like a little Mo.js animation for like a firework. So if they got 99, we do a small firework. If they got 100, we do a bigger firework. Don't need to worry too much about those. And then we fire off the burster. The little firework thing. And then this right here, this is just a big set state. So this trigger, when they're doing this, usually in a class, this would be like this dot set state. But since we're using hooks, this set state comes from our React use state up here at the top of our app. So we can take set state and it's just a big function. We're saying, hey, this is all the previous state. We make all of our changes and our calculations, and then we say, hey, here's the new state. So it is, you do have to return the replacement object for the state. It's not like the class this.setState, if I remember correctly. You have to return the entire object will replace it. So it's just like an immutable function now. So you have to spread the old props on there, or the old state, and then replace the new ones. I kind of assumed that it was going to be additive like the old one, but it's not. Which I like it. I like it better to be this immutable one, because it's cool that you can replace all the state if you want. And then this handle key down is just handling the space bar. So it's like, okay, if the key equals space or the key code equals 32, then call the trigger. And that's it. Now, and then also if you click the bottom color box or the trigger button, it does the trigger. So that's kind of like the overall architecture of the game. Really the part that everybody probably wants to hear about is how the heck does this oscillator work? Well, this oscillator is a custom hook, and custom hooks are just functions that you can call at the beginning, like right along with other hooks, and you can treat it just like its own hook, but it's a function that basically calls its own hooks under the hood. And this is abstracted. It didn't technically need to be abstracted for this app, but I did it anyway, so that you can kind of get the feel for a custom hook and how it might work. So this oscillator, if you remember, I'm passing in run, and this is just a Boolean whether it's running or not, the speed, and the initial value. And this oscillator technically has state. It has that value that it's rotating and adding to and kind of like looping around the 0 to 1 decimal range. So inside of my hook, I can use React state, just like I did in my normal app state, but this is just for this oscillator and just for this instance. So I say React use state initial value. So I pass it the random value that it starts with. Like there it was just green, and there it was red, and there it was orange. So it just says, hey, start using some state with this initial value. So it's going to be like some decimal. And same thing with all other React use state hooks. It gives you back an array with the first value being the value and the second one being set value. And then, so basically our goal here is to we want to be rotating this value on a regular basis if it's running. So to do that, we use RAF and request animation frame. And we'll come back to this in a second, but this is really where most of the magic happens. We know in the end we are returning the value, like the actual decimal value, so that we can use it. And if you look right here, use oscillator, it returns the oscillator value. So we know at least that we're returning a value, so we return it. And that's the value coming out of use state. And then we know that we want to increment that value on a regular basis. Like pretty much after every update, we want to make sure that it updates again unless we're running. So we use useEffect here, and useEffect is one of React's hooks that is currently, I feel like it's being misunderstood as like a lifecycle hook. It's really not a lifecycle hook. Like useEffect is or can be something that literally runs after every render, depending on what you've passed it, right? And so yes, it can do things like component did mount or component will unmount, but really we need to stop thinking in terms of that and just think of something that, hey, this effect will happen basically after every render or when these things change. And then if the component needs to unmount or aka unwind, like undo some of the things that it might be waiting on, then it returns a function to basically you're teaching the effect how to unwind, how to like cancel things that it might be doing up here or unsubscribe from things. So after every render, it's going to check to see if the run, the value, or the speed has changed. And if any of these have changed after a render, it's going to run this effect. And then inside of the effect, we are saying, we're checking if run is set to true. So if we have passed run false to our oscillator, we don't want to request another animation frame. So this will only run if run is true. So if it is running, then we're doing a new request animation frame, which is just a function that says run this function the next time you have a frame, like an animation frame to do it. So this will be run at 60 frames per second, then the next available 60, highest frame rate basically. And then it says if the value of our oscillator is greater than or equal to 1, then set the value to 0. And that's how we create the loop. So if it goes to 1 and it's higher than or equal to 1, then it goes back down to the bottom. And then if it's not greater than or equal to 1, then we're just increasing the value by the speed. And this is interesting because set value right here is using use state. It's the setter for this state right here. And you notice how you can use like just the straight primitive set, like you can pass it, you know, a new value to be set to. But if it depends on the old value, this is why the functional set state is so important, because set value, you know, just like the old like this dot set state, and you could pass a function, same thing here. It relies on the old value to increment. So you pass it a function where this used to be, you might be familiar with this being like an object of state, but now it's just the primitive value, the old primitive value, and then you return the new one. So these are basically the same thing. This is just relying on the old value in some way. So we increment it by the speed, which might be like 0.001 or something like that, depending on where they're at. And then we teach, so we have to teach the component how to cancel that animation frame if something goes wrong, or if it starts to unmount, or if run or value or speed changes. We might not want the next request animation frame to happen, or this one that's queued up. So what we're doing is we're keeping track of the instance of this request animation frame right here. So you might be familiar with useRef from React as something that's for like DOM references or node references, but a ref in React is not just for DOM references. And in fact, this hook is now pretty much the best way to keep track of mutable values across renders. And you probably won't use it a whole lot, but in this case, we needed to keep track of this instance to make sure that we could cancel it or override the current instance if we need to. So I make a variable called instance, and I make it a new React ref, and you can pass the initial value right here if you want, but I just don't pass anything because it doesn't have an instance yet if it hasn't run. And then right here, when we call request animation frame, it gives us back the request animation frame instance, and we assign it to the current property on the instance. And this is just to keep track of it. And then we return a way to unwind it, and we use that same instance.current with raf.cancel. So if anything happens or goes wrong, or the component starts to unmount, this will cancel the current or most recent instance of our raf right here. And then this one is actually pretty cool too. We could have probably worked it into this same effect right here, but I wanted to use a different one because I wanted to track it differently from run, value, and speed. Like this one's running a lot. Like basically, if you think about it, that color oscillator is like it's using set state like at 60 frames per second, right? And that's what this is doing right here. Every time that the component updates, it's checking run, value, and speed to see if they've changed, and value basically changes all the time unless it's running. So this is effectively calling itself over and over again, updating that color. But I didn't need to be in that very like aggressive loop to know if the initial value changes, because if the initial value changes, then I just need it to jump to that value and then keep oscillating. And if it changes again, jump to that value and keep oscillating. So right here, I have another use effect where I say, you know what? If the initial value changes, I want you to run this effect. And I cancel any open instance that's going to happen. I have to cancel the request to the animation frame because this might be trying to set the value to the next like loop value, right? And it could technically override this set value of initial value unless I cancel it. So if there's still an animation waiting to run, I cancel it using that instance.current. And then I set the value of the oscillator to the initial value, so I jump it to where it needs to be. And that effect runs, and then after that, all these values in here will be updated to that initial value, and it will just keep running. You can see that when I click on this this orange one, or this yellow one, you can see the bottom value randomizes, but then it keeps oscillating after that. So it just turned purple, In fact, blue again. So just turn, let's see, turn blue, turn orange. Well, I don't know what happened there. I'll have to check out that bug. Oh, actually, I think that's from just some hot reloading issue that I've been seeing with Code Sandbox and hooks, but it's probably not a big idea or a big deal. You can just hit that refresh button right there. And then, yeah, that's really it. So when any of these things change right here, we're running an effect that is requesting an animation frame, if it's running, to update the value. And if the initial value changes, we're like stopping the request animation frame, and then we are setting the value. And then after it updates, it's going to say, hey, the value changed, so it's going to kick off that oscillation again. So if you look at this, there's state inside of here, there's instance, like there's component instance references, you know, there's an effect for the initial value, there's effects to detect changes here, and we kind of like made our own little homegrown loop here, and it's got all the stuff to unwind itself right inside of here. And this is just a function. That's what's so cool, is this is not like some render prop or higher order component or something like that. It's just a function, and it's going to hook into whatever component that uses it, really is what it is. When you say React use state, like this state and this ref and these effects, they're all going to be bound to and scheduled on whatever component they're being used in. So we're using this oscillator in our main app, and so this use oscillator call is saying, you know what, use the oscillator, and any hooks that get called inside the oscillator are going to be bound to this app component. Really pretty genius. The more I look into hooks, the more it makes sense. It's you know, it's a type of algebraic effect, I guess you could call it, and where you get to declare your state and declare your side effects in a very declarative way, I guess. Instead of being so imperative and separating your logic out and handling life cycles on your own. It's much more declarative, it's easier to reason about, and like as a consumer of one of these hooks, it just becomes a function, which is great. You're saying, use the oscillator, here's the current stuff, give me the current value, and this is stateful, but we don't have to use a special syntax to know that it's stateful or to use its statefulness. It's just a function. It's beautiful, in my opinion. It's completely ruined me for classes. Like, I have a massive app at nozzle.io actually that's written in all, you know, in traditional React, and there's so many classes, and it's all state and everything. And man, I would really love it to be able to just go and just blow it up, be a bull in the china shop, you know, and just break everything and turn it into hooks. And I probably will, but not for a few months, because I got to keep things stable. But as you can see, this is just our app is a function, and that returns JSX, and that returns markup, and all of our state and timers and effects and side effects and everything are all just functions. It's amazing. There's not a single class in this entire app. So I hope you guys liked it. Go ahead and play it. Let me know what you think. You could find the bugs in it. Maybe you can get past level 30. I'm sorry if you suffer from some type of color blindness. I have not figured out how to make it more fair for you. I don't believe I suffer from color blindness because I think I'm pretty good at it. But that'd be really cool if somebody could figure out how to make it work for people who suffer from different color blindness problems. But sorry, I don't want to call it a problem. Color blindness is something that you don't have any control over. So hope you guys liked it, and I will hopefully have more stuff like this soon, talking about hooks and talking about how to change from classes to hooks and how it's amazing. See ya.